In this video, we'll take a look at the two problems on quiz number 2 that were missed most by the class. The first one is multiplying complex conjugates. So about 30% of the class missed it, so let's take a look and see what happened. So we want to find the product of -3 plus 6i and its conjugate. The conjugate, if you have a plus bi, the conjugate is a minus bi. So notice it's the opposite of the complex portion. So if we have -3 plus 6i, then the conjugate is -3 minus 6i. Notice nothing happens with the real part, it's just the complex. So when we multiply these together, we get -3 plus 6i times -3 minus 6i, and we're going to go ahead and do FOIL, or distributive property. Make sure we multiply everything in the first number, -3 times -3 minus 6i. Then we're going to take plus 6i times -3 minus 6i. When we distribute it, we end up with -3 times -3, which is a positive 9, -3 times a -6, which is a positive 18i, 6i times -3 is a negative 18i, negative 6i times negative 6i is a negative 36i squared. Now from here, we simplify. I just want to get a little bit more room. So simplifying, we take the 18i and the negative 18i cancel each other out. So that should happen every time you multiply a complex number and its conjugate. The middle terms will cancel. We have I squared. I squared is equal to -1. Remember that the imaginary number I is equal to the square root of -1, so I squared is equal to -1. So now we're going to substitute 9 plus 36 times -1. So we end up with 9 minus 36, which is equal to a negative. So notice what happens is all the complex portions end up becoming a real number, and we end up with a real number in this case, which is -27. So the product of a number, complex number, and its conjugate will always be a real number. All right, next problem was solving using the quadratic formula, where you end up with complex numbers as a solution. So in our quadratic, notice that we have 2t squared minus 3t plus 10 is equal to 4. It has to be equal to 0 before we can identify what a, b, and c are. So the first step is to subtract 4 from each side, and we end up with 2t squared minus 3t plus 6 is equal to 0. So a is equal to 2, b is equal to -3, c is equal to 6. So in our quadratic formula, x, or in this case it's going to be t, is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Substitute our values in. We end up with a -3 plus or minus the square root of, in parentheses, -3 squared minus 4 times 2 times 6 all over 2 times a, which is 2. So off to the side here, I'm going to go ahead and simplify the square root. I'm going to keep the 3. Negative is 3 plus or minus the square root of over 4. And now we're going to simplify the square root underneath. So a little bit of scratch work. -3 squared means -3 times -3, which is a positive 9. Minus 4 times 2 is 8 times 6. So we're going to end up with 9 minus 48, which is going to be a negative number. I end up with a negative 39. So negative 39 is what is in the square root. So this is a complex number because we have negative. So to simplify the square root of negative 39, that means that's the square root of negative 1 times 39. The square root of negative 1 times the square root of 39. Negative 1 square root is I. 39 inside the square root we can't simplify because it's 3 times 13, and neither one of those are a perfect square. So we end up with t is equal to 3 plus or minus I times the square root of 39 all over 4. And nothing else can be simplified. So a couple of errors I noticed is writing I inside with the square root. So just make sure if you're going to write I on the other side of square root of 39i, that your square root of 39 is distinct away from the I instead of the square root typing 39i.